Well, let's try to do another question. In this question, we have been given a beaker which is filled with water, and there's a point P here. Now there are four rays starting from point P: A, B, C and D, in such a way that ray A, it goes out normally, is moving upwards normally, strikes the water air interface at right angles. Ray B is at an angle C and D. Ray C, the angle of incidence for ray C is given to be 48 degrees. Angle of incidence for ray C is 48 degrees. The question is, draw the rays as they emerge out of this water. So how to do this kind of question? Complete this ray diagram. So given that critical angle for water is given out to be equal to 48 degrees, and we can see from this diagram that this ray C, the angle of incidence is equal to 48, and that is equal to the critical angle for water. So how to complete each of these rays as they emerge out? What happens from water to air? They are going from denser to the rarer medium. So let us see how to draw the diagram. To do that, we'll take this here. I've done this for you. Ray A goes straight, unbent. Normal incidence, it emerges out straight, because when a ray strikes a medium at 90 degrees, normal incidence, it goes straight, unbent. Ray B, for ray B, we find the angle of incidence is less than 48. This angle is 48. This angle of incidence over here is less than 48. The angle of incidence is less than the critical angle. Hence the ray gets refracted. It moves out into air, moves away from the normal. This ray C, it is striking at the angle equal to 48 degrees. That is the critical angle, and we know that as per definition, if the ray strikes at an angle equal to critical angle, corresponding to which the angle of refraction is always equal to 90 degrees. So ray moves along the surface of water. So angle of refraction is equal to 90 degrees. For ray D, in this case the angle of incidence becomes more than 48. That means more than the critical angle. And if angle of incidence is more than critical angle, the ray will be totally internally reflected. It will not cross into air, rather it will get reflected back into water. So total internal reflection of light. So ray A and B, they suffer refraction because angle of incidence is less than critical angle. Here it is equal to critical angle. So ray moves at 90 degrees to the surface. And for ray D, here the angle of incidence is more than the critical angle, and the ray gets totally internally reflected. So here you can have a look at this. Ray A emerges out normally. Ray B undergoes refraction. Why? Because angle of incidence is less than the critical angle, less than 48. And ray C goes along surface of water because angle of incidence is equal to critical angle. So angle R is equal to 90 degrees. And ray D undergoes total internal reflection of light because angle of incidence becomes more than 48. It becomes more than the critical angle. Hence the ray gets reflected back into water. Now we have another situation here. The angle of incidence is given to be 48, and the ray of light, it is going from water to air at an angle of incidence equal to 48 degrees, and given the critical angle for water is 48. That means angle of incidence is equal to 48 degrees. Now how will this ray move? Whether it will go out or whether it will get totally internally reflected. Angle of incidence is equal to critical angle, and as per the definition, we know that if the ray of light strikes at an angle equal to the critical angle, it gets refracted in such a way along the surface. The ray should get refracted along the surface such that angle of refraction is equal to 90 degrees. So let's look at that. Here, there you are. The incident ray strikes at critical angle 48 degrees. It gets refracted along the surface of water such that angle of refraction is equal to 90 degrees. Angle of refraction R is 90 and the ray gets refracted along the surface of water. Why? Because angle of incidence is equal to critical angle, that is equal to 48 degrees. Now here we have another situation. A ray is made to fall from water to, it is going from water to air, and the angle between the surface of water and the ray is 48 degrees. Critical angle is 48 degrees. Question is, what is the angle of incidence? Lots of boys go wrong over here. They take 48 degrees as angle of incidence, but as per the definition, that is wrong. The definition is angle of incidence is the angle between the normal and the incident ray. So this is the angle of incidence, not this. So what is given over here, that is not the angle of incidence. Lots of students, they just take this 48, angle of incidence is 48, and draw the refracted ray along the 90 degrees, but that is not correct. In this case, first we have to calculate the angle of incidence, and let's see how it is done. There you are. So angle of incidence is equal to, this whole angle is 90, this whole angle this being a normal, 90 minus 48, this angle is 90 minus 42. We will first calculate the angle of incidence, angle between the incident ray and the normal. Angle of incidence is 42, it is not 48. Lots of students write angle of incidence is 48. No, angle of incidence we will have to calculate. Angle of incidence is 42 degrees and critical angle is how much? 48 degrees. Now, since the angle of incidence is less than the critical angle, 42 is less than 48, angle of incidence being less than the critical angle, hence the ray will move out into the air, it will get refracted, and since the air is a rarer medium, angle of refraction is going to be larger than 42. Angle of incidence is small, angle of incidence will be large because the ray moves away from the normal. Refraction will take place. Refraction will occur because here the angle of incidence is less than the critical angle. The previous case, angle of incidence was equal to the critical angle. When angle of incidence is less than critical angle, in that case we have the ray goes into the second medium, gets refracted.